Thanks everybody for joining. I'm Ido from lakeFS. With me is Amit. Hi, Amit.
Doing good, thank you.
Yeah. I'm Ido with lakeFS. With me is Amit. Hi, Amit. Obviously, you said hi. I just didn't hear it. And we're here today to talk about some useful ways to create a safety net for running Databricks ETLs. Before we begin, we just want to know a little bit about the folks that are here. So we're going to ask a little bit of questions about who are we speaking with and how familiar are you with the technologies that we're about to talk about today, or lakeFS specifically, so we'll know how to address it. Amit, if you can perfectly just help us focus on how deep we need to go into lakeFS and what is your role. So we'll talk about the right use cases. Perfect. And as you are answering this, I'll give a little bit of background of what it is that we want to speak about today. So basically speaking, we're gonna try and find a better way together to promote ETL codes to production with lakeFS. And to be honest, without lakeFS, there is theoretically a very easy way that people do it today, and I think we can close the poll. Perfect. There's a pretty easy way to do it today, which is if I need to write my ETL, I typically have the code of my ETL stored in Git, and I will create a branch out of that code. I will make whatever changes I want to make, and I'll commit them. And then when I want to promote this change, then I will run a pull request in Git. That pull request will probably run some automatic tests that you have in your environment. I don't know, making sure that you don't have security breaches, making sure that best practices are in place, whatever it is that you want to do. And then if all those Git actions pass, we go and we promote the data to production. That's kind of what we do today. Amit, you've been doing this for a while. Seems like it's all working. So what's the problem with this approach? Why are we here to talk about fixing something?
Yeah, so people are familiar with this kind of process where they test their code with some sample data, and then they promote their code into production. But the challenge is like there is no concept like promoting the data or testing with the real data with your production data before you promote both code and data into production. So that's very kind of missing piece right now.
Yeah, it's interesting because the data, like no matter what you do, the data that you tested against is not the data that you run against in production, right? So like usually people sample or copy data to the side, but it's typically not the same data as production. And even if you went and you copied all your data to production and then you develop against it, by the time that you actually deploy your code, the data is already not the same as what it was before. So in practicality, what we do is we're testing in production, right? On these ETLs. And today we want to talk about a new way using lakeFS. So, Amit, can you share with me like approximately what percentage of people are familiar with lakeFS on this call?
Very few are familiar, so we can go in detail about lakeFS.
Okay. Thank you. So what lakeFS does is it's a Git for data solution. It basically takes an object store, whether that's an object store on premise like MinIO or Dell ECS or NetApp Storage Grid. There are many out there, or an object store on the cloud like Amazon S3 or Azure Blob Storage or Google Cloud Storage. And on top of that object store, we give a Git interface. So imagine that you can take a bucket or a collection of buckets or what we call a repository, and you can branch them to create a copy. This is a zero copy of your data. And then you can work on that copy in isolation. You can make changes. You can commit those changes. If you're unhappy with those changes, you can roll back those changes. If you are happy, you can make changes in one branch and then merge one branch to the other branch, and just like you merge in a pull request and promote changes into your data, just like you will do for code. So, and then the ecosystem of tools that you have in your environment can access the data through a lakeFS API and get those branches. That's lakeFS at a very, very high level. That's what we do. Now, why is it useful to have branching mechanisms and production environment or data environment, because many times when I develop against data, the development environment and the production environment, especially in the world of data, are completely separate. So I cannot physically develop against production data. I don't have access to production data. So at some point, I'm going to have to promote code that I wrote and tested to my best abilities to production to run against production data. But we think that there is a really good way to do this, right? So if before we're using Git to version the code, now we're going to use lakeFS to version the data. And the process is the same, right? I have an ETL. I want to write an ETL, so I'm going to create a branch in my code, and I'm going to make my changes, commit my changes, and then I'm going to promote this by running a pull request. The difference is that we're now going to take our Git action, and our Git action is actually going to execute something in lakeFS. So the Git action is going to create a data branch. So I'm going to take my production data, and I'm branching that data out. So this is a CI/CD process, right? I take my production data, I'm branching it out. It's a zero copy clone. And then I'm going to run the ETL on that branch data. So I just change my code. And before I go and I finalize promoting that code to production, I'm running that code against my data, my actual production data. And only if this passes, I will go and I will merge the data to production. So this is a bulletproof way to make sure that whatever changes I made in my CI/CD right now to my code have been tested at scale in production and they passed, right? Now, a little bit about, Amit, anything to add here?
Yeah, just I think you already mentioned, but just to reiterate that we are not running this directly against your production data. We are creating a separate zero copy clone environment, isolated environment for running your new code. Just to say it again.
Yeah, triple time. Yeah, this is a very important thing. Thanks for stressing this. The way that this works is the data will be sitting in your bucket, and with lakeFS, every commit is a collection of pointers to objects that sit on top of your managed bucket. Okay. Now, object store, as we all know, are immutable, right? So if I want to go and I want to change this file, I don't actually. What I actually do is I write a new version of this file. We take advantage of this property and we do copy and write. So the next commit will point to that additional file. But files that did not change, like these three files over here, you will have multiple commits pointing to the same physical objects. And that's very powerful because if I have, I mean, lakeFS is, actually, I didn't mention this here. lakeFS is an open source solution. We have thousands of organizations that we are aware of that are using lakeFS. Some of them have hundreds of petabytes of links. Creating a commit is a metadata only operation, which means that A, it's highly performant, right? So when I want to go and I want to work again an isolated copy of my data, automatically test, it's going to be really, really quick to create a copy of my data that I can test against. And B, because I'm actually not copying anything, but only manipulating the pointers, excuse me, it's also not going to cost any additional storages. So that's how lakeFS works. So we want to show you this now in action. There's a lot of moving parts here, so we're going to show it to you. And basically, the demo that we're going to show you is going to have two parts besides lakeFS to it, right? One is we're going to have some configuration on Git. So on Git, we're going to configure a Git action. And that Git action will do exactly what we mentioned in that demo. It's going to go create a branch, run the ETL, get a validation, and tell whether or not the ETL is successful. The ETL, we're going to take an ETL job that we're going to change in our Git repository, of course, and then that will be moved to be run on Databricks when you run it. We have here basically three Python, we have four, but the three that's worth talking about right now, three Python codes, one to create the lakeFS repo and import the data, right? So obviously, if if you have your own production data, you can use that as well, and that's the idea. But we're going to create a lakeFS repo and import the data from your production environment. Then we're going to run the ETL, and the ETL is going to be smart enough to know, am I running against production and I need to write back to production? Or is this a pre-prod test, right? Or a CI/CD test in the deployment to production, and then I'm going to write this to the separate branch. And at the end, we're going to run the validation to see if this worked. Now, here we wrote Python code. You can run anything that you want. So you can use Scala, for example, if you wanted instead. But we have a Python example that we're going to show you here. We have Scala documented as well. The validation is also a Python code. Obviously, you can also just use like if you have a great expectation or whatever tool that you want to use to validate that the ETL is successful, you can use whatever tool that you want as well. But the idea is, again, that I'm going to change my code in GitHub. I'm going to run a pull request. That pull request is going to execute on the Databricks side a process that will import the data, run the ETL across an isolated branch, and make sure that everything was successful. I want to pause here for a second, see if anybody has questions.
No questions so far.
Okay. So, Amit, I'm passing this to you.
Okay, thank you. Thank you for explaining the whole process. So let me share my screen. Ido, can you confirm you can see my screen?
Yes.
Okay, so I'm going to hide my Zoom controls in case if anybody asks any question, let me know. Okay, so let's start. So this is our samples. This is a sample repository which I'm going to use for this demo. And this sample is available online. So if you want, you had the QR code in the beginning of the when we started, or you can go to lakeFS samples, search for lakeFS samples. So this is what I'm using today. And you can take this and create your own Git repository. So this is my own account. I have this sample repository I just created for CI/CD purpose. And it has my ETL code. So this is my ETL code, ETL job. It's a very basic, simple one. So let's say I'm making a change in my ETL job. Everything is stored in my Git repository, but sometime you might have this code in Databricks environment. You can have that notebook in Databricks, but you might check into or commit into your Git repo. So it's up to you where you want to develop. Sometimes people use IDE to build their ETL job. So this is, let's say I'm just going to use the Git today, Git interface to make the changes in my ETL code. And for this demo, we are using some sample data set, like sample tables. There are 2 tables I'm using just to show the parent-child relationship. So in this ETL job, we are just partitioning data by a country. So there's a famous people table, and we are just partitioning it by country using a Spark and run this on the Databricks environment. So let's say if I want to make some change, I already had this some changes here, which I had commented out earlier. So let me uncomment this. So let's say I made some changes in my ETL code. In this case, I mentioned earlier, we are using a sample table, which is a famous people, and famous people, we have categories for those people, whether they are athletes or that belong to the music category. So different categories are there. So let's say I made some changes in my ETL code. In this case, I am deleting a category called music, for example, but I'm deleting just from one table right now, not from both the tables. So there are some famous people of music category in the other table, which I am not deleting. So I'm deleting only from one table, and let me commit my change. So again, this is just creating a new branch in my Git repository. So you're not committing to the main branch, but creating a separate branch here and commit my changes here. So very basic, simple ETL job here, just to show this. Now, once all my changes are done, all the commits are done, I can create the pull request. And when I create the pull request behind the scene, it is going to invoke the Git action. So this action starts whenever the pull request gets created, or if you commit any changes, new changes to the existing pull request. At that time also, it will trigger this Git action. Anything else, Ido, I missed you want to add before I go into more detail?
No, this is fantastic. So you can already see the run Databricks ETL job in isolated environment using lakeFS. This is, and of course, the purpose of this meeting, we're gonna walk you through step by step exactly how to do this. But we wanted to start with like this demo of showing you, I made an ETL change, and now what's happening is that change is executed against an isolated copy of my production data. We'll see if it worked or it didn't work. And if it didn't work, we're not, like, the pull request is not going to be approved. And I'm sure that many of us here are using Git anyway, so this is just integrating into the ways that you operate today.
Okay, so let's look into
I see
more
a question
detail.
on the Q&A, by the way.
Okay.
Are there any limitations on the underlying number of write stages to given ETL? Number of files in object stores that users should be aware of?
No, there's no limitation on number of files or the how many number of writes you have. Of course, this process will take time to run this process will depend upon how much your work you are doing in the ETL job and also how much data you are processing. Sometime when you are testing in the dev environment, you might limit the time frame or something. So let's say you have terabytes of data or petabytes of data in your production environment and you are testing this ETL job, you might run it just for the smaller subset of that, like specify field or parameterized by, let's say, start time and end time, or parameterized by something else so that it doesn't take hours and hours to run.
Yeah, if this is like a 12-hour job and you don't want to wait 12 hours for the pull request to test, then that's okay. Having said that, just to give a little bit more context as well, lakeFS is from the ground up used for big data, designed to run for very big data environments, and we are running in some of the world's largest lakes, making hundreds of millions of API calls a day, right? So there's API call being storage backend calls mostly a day. So there's no limitations on that, and it can scale with more. There's also, like I mentioned, it's an open source resource. You can go and look at the sizing and ways to scale this to support more and more data, but it's meant for this. It's meant for big data at scale.
So while we were talking, so I think this process ran and the validation failed. So we'll look into more details. But once the validation fails, you cannot merge this pull request into the main branch. So let's look into what happened here. So let's go into the details here. So what this is, basically, if you're familiar with the Git action concept, it's basically running this Git action behind the scene with multiple steps. These have multiple steps here, and the validation failed. Let's look into the first, what the error message is, why the validation failed. So if you remember, when I mentioned earlier in the ETL job, there are two types of table. One is the categories, like different types of categories like music, athletes, and then there we have famous people. This is just the sample data as part of this demo. And I deleted the category music from one table, but there are a lot of famous people belonging to music category, and I did not delete from the other table. So there's a referential integrity issue. So we are checking like how many categories are there in both the tables. And then if the categories are not, number of categories are not equal, and then fail this check. So you can do any kinds of check. There's no limitation. It's up to you what business checks you want to run. Sometime, let's say you have orders table, you might have order master table and the detail table. You want to check order totals in the master table equates to the order details table. So any business logic, any validations you want to do, you can run through this. This is just a simple validation I did here. Anything else to add before I go into all the steps here? Anything else, Ido?
No, so just to make sure we're all aligned at this point, up at this point, I hope everybody understands this is like the final product of the step by step, right? So we created we configured everything together, and now the ETL ran. In this case, there was a mistake in the ETL. There's some sort of data integrity problem, so we cannot actually promote this. We cannot promote this code to production, because we tested that. We tested that against production data just before this code ran into production. And of course, now we can fix that. So that's where we're standing right now. If anybody has questions about that so far, please feel free to put them in the Q&A. Otherwise, next we'll also show you how we configure this.
Yeah. Okay, so now let's look into more detail here. So here, this action has multiple steps. So if you remember, in the presentation earlier, they talked about creating a separate branch or creating a separate repository, lakeFS repository, and import the data, which is zero copy import operation. So this is also done through a Databricks notebook. So if you expand this kind of a step here, and it has a data notebooks with a link here. So if you just click on this, it will straight away take you to that Databricks notebook run. That particular run which ran just now. So here you can see this is only that particular run. So anytime you change your ETL, you commit your change, every time it will fire that action, and every time it will call this, for example, this notebook. What this notebook is doing is creating the lakeFS repository and creating a separate branch, importing the data, and then creating a separate branch isolated testing environment to test your ETL code. So here I'm just getting all the argument parameters and then creating my repository, lakeFS repository. I'll show you how the lakeFS looks like, and then import my data set. Again, just to reiterate, import process is just bringing the metadata. We are not copying the data. It's a zero copy import operation, just getting the metadata from your object store. In this case, I'm using S3, so it's importing data from S3. And so this operations runs very fast. Even if you have terabytes or petabytes of data, it will take a couple of seconds to import your production data. Again, we are not going to impact your production data. We import that in a separate, in lakeFS repository in a separate branch. And then you run the ETL job against that. And if you when you change anything in ETL job, we are going to copy that into lakeFS repository, not to your production storage or production S3 bucket in this case. So just finish this import process here, and then it will tell you the lakeFS branch where it's going to run. So here we just create a new branch in lakeFS, very similar concept as Git. In lakeFS, we just created a new branch. And so if I click on this, it will straight away take me to the lakeFS environment. So I think this is first time we are showing this lakeFS UI, but so far, whatever I did, everything I did through API, but let's look into the UI also. So here I created a separate branch. So here I'm dynamically creating this branch name, which is a PR number 11. And this is my commit ID in Git. So whatever commit ID I have in Git, we are passing it to lakeFS to create the branch. So anytime you create a new commit, it will create a new branch, unique branch in lakeFS and run your ETL job against that branch. So if there are multiple people working together in a team, each one committing their own changes, they will have a separate branch in lakeFS to test their ETL code. Okay, so let's look into this. So this is my delta tables here. In this example, I'm using delta table, but it can be a Parquet table. It can be anything. It can be any thing you can store in object store. So as I mentioned earlier, there are two raw tables we have. One is category and the famous people, and then we partition it by country. So those are the three different tables here. So this is like you can quickly look into This is my raw table, famous people, which I initially imported from my production source. So if I go into and look into the object information in lakeFS, so you'll see that this is pointing to S3 to my data source, original data source. So again, this is just the pointer. We are not copying any data again. Just to reiterate, it's just all these files are just the pointers to your production data. But if you change anything, that will get copied into lakeFS repository only. It will not copy into your production bucket. So like, for example, I deleted a category called music. So let me check if this is stored in this Parquet file. No, so there's one.
Likely the one from 9 minutes ago.
Yeah, let me check this one. Thank you. Yeah, so here I deleted a category from my table, but instead of writing to production, it is writing into my lakeFS repository. So you will not corrupt anything in your production data. When you run your test, everything is any writes happening into lakeFS repository side, but existing files we are pointing to your production S3 bucket. So we are reading from production, but writing to lakeFS repository.
Yeah, I think anybody running any ETL that does any type of retention, deletion, or something like that, that's always when your fingers kind of shake. This is a great way to make sure that you don't accidentally delete half of your user base, right? Things like that.
And just quickly walk over like here, you can compare similar to Git, you can compare different branches. So let's say I want to compare my main branch to this new branch and see what changes happened here. So you can quickly calculate the summary. So there were about 16 objects were added and one object was removed, or basically when you change anything in object store, it removes and adds a new object. So that's what it is. And then when you go into detail, then you can look into for each one, what changes happen in each table. For example, in this famous people was the new one, which we partitioned by the country. So that's all new. And in the category, we deleted one music category. So that's what it is showing, that one file got deleted. So you can easily compare the changes happening between the different branches, in this case, comparing to your production data set. Anything else to highlight here, Ido?
Just in passing, one of the things that we mentioned that when we looked at that Databricks is that all these creating of commits and creating of merges and branches and writing files, you can do those from this UI, but you can also do those from an API and SDK. And in this case, there's Python code running within those notebooks that this is like the Python client of lakeFS that basically just creates these branches and does everything, which is makes it very simple to integrate.
Yep. Good. So that was like the first step. And the next step was to we print this ETL branch. I think we already saw that branch got created in lakeFS. So the linkage URL is here also in case you want to go back and look into again. So that linkage also there. Then once we have the lakeFS repository, then we are going to run this, basically run this ETL job, which is running in the Databricks environment. So let's open this notebook.
So this is the ETL that you just wrote, right? This is whatever it is that you promoted to production.
Okay. Yep. So I think let me just mention something here, which I think Ido mentioned earlier also, like when you are running this ETL job for production environment, so we are passing the environment. So if it is production, then it goes straight to your production data source. But if it is development or test or whatever you want to call it, then it goes to lakeFS repository. And then it has the lakeFS repository name, the branch it is running against. So if multiple people are running at the same time, committing the change at the same time, it will create a unique branch for each user, for each commit in lakeFS. And it will give you here it tells you whether this is running against the lakeFS data source, not to your production. But if you pass the production environment, then it will run against the production data set. So, and when it is in the dev, basically, as I mentioned earlier, this is the the branch we are running against. So this URL is again available here in case you need. And so here we are just partitioning by country. This is my famous people table, reading my raw data set and writing to the famous people. If you are familiar with the Databricks medallion architecture, raw, silver, and gold, and that kind of architecture you can implement. So that's my famous people table. And here I deleted a music category from my category table. So now I have only 3 categories here. Earlier I had 4 categories. Now I have only 3 categories. But here we have these category codes. But I did not delete from famous people table that category. So there are some people who are belonging to music category which are in this table. So that's the ETL job which ran. So after the ETL job finishes, then next thing you do is run your validation checks. And again, it can be any kind of validation. This is just a sample demo here. So let's look into that notebook. Again, the validation notebook is also running in Databricks environment. And again, we just connecting to lakeFS repository, and then committing my changes, all the ETL changes that we did. We just commit those changes. So let's look into that commit also. So there's a link to go to the particular commit in lakeFS. So you have commits, you do commit in the Git side, which invokes this code. And then when you run the ETL job, you make your changes, which is written in lakeFS. You commit those changes in lakeFS. And here it will provide you all the details about who committed this change and what was the parent parent commit before this commit happened, and all the changes that happen in that particular commit. Again, we saw this earlier. And from each individual commit also, it will provide you the direct link to go to the Databricks notebooks. So like this was my first data notebook I ran, created my repo and imported my data. So if I open that, it will just straight away take me to the to Databricks notebook, which I ran. So we provide full integration between Git, Databricks, and lakeFS. And this is my ETL job, which I ran. So going back to my ETL job again. So we saw the commit information. Actually, I've already covered the ETL job. So let's look into my validation here.
And it's worth mentioning that these, sorry to jump in, that
yeah.
these metadata that are part of the commit, they can be expanded, and they typically expand it to even a lot more. So it's super powerful that you can go to every commit and you can just go and see, oh, this is the notebook that actually created this commit. Especially if something fails, right? And you want to go see what the data looked like, what the code looked like, and you have this entire triage, which is very useful. But also, if you want to do this not with Databricks, if you're using like an Airflow or a Dagster or a Perfect or any other orchestration system, there's also, it's very common practice to also integrate here, like this is the link to the DAG that actually created this commit. And the opposite, from the DAG, this is the link to the commit that was this step within the DAG and things like that. So this is a easily expandable feature that is very widely used to integrate in a very decoupled way between different solutions.
That's I think, thank you for adding that. There's a good point. Like a lot of things you can add, including the metadata here. Like, for example, I did not do it. I just realized we could have put all the parameters that we are using to run these notebooks and record here in the metadata. So you'll know like what parameters were used to run these notebooks. So thank you. So next here in this validation check, what we are doing is looking at the categories, counting the categories, like how many categories are there in the parent table, the master table, and how many categories are there in the detailed table, in this case, famous people. So after my delete, there are only 3 categories in this table and the 4 categories here. And we are just validating the number of categories. If it is the same number of categories, then we return a success to Git action. So here, when you finish this, you return success, or you do a customized error message. So in this case, I'm returning a customized error. So if you are doing multiple checks, multiple validations, you might call multiple notebooks to run the validation. So after all the checks are done, then you return a success. And if any validation fails, let's say the first validation failed, you can just exit and return the error message. So it will not run for the whole thing. So it depends on how you want to handle it. So in this case, it returned the error message. So that's what we are capturing here. This is the custom error message that was returned by the notebook. And again, as I mentioned earlier, you can use any third-party tool to do all the validation and then return the error message to the Git. And once it receives the error message, it will just fail the merge process to the main. So this is like a failure. I will show like how to fix this and then run it, how it will run successfully. But before I do anything else, either you want to add?
No, I think this is fantastic. There's as you fix this, I'll just talk over fixing this with the deletion of the category.
Yep.
That this is also very well documented in the samples, and we'll share the link again at the end of this. But it's there's a bunch of configuration here that needs to be done. Actually, the lakeFS code is the easy part. So it's all very well documented here, so please feel free to follow the steps that are written in the GitHub. And we will talk about them quickly, but feel free to do that in order to create a similar environment in your environment.
Yeah. So let's say this was by mistake, I deleted a category by mistake in my code. So I fixed this, and I'm going to just commit that code or delete that, remove that code, and my commit my changes, and I'm going to commit it directly to the same branch. So once I commit, let me go into my pull request. So here, once I commit that change, it's going to rerun this process. Again, it will go and fire all the Databricks jobs and run the ETL job again, import your production data again. Sorry, I forgot to mention, because the data might change over time. So let's say you fix this code 2 days later. So it will re-import the data. And again, the import is 0 copy. So it will import it very quickly, re-import the data and run the ETL job again against the latest data set. So that's also very important. Like every time it's going to bring the latest data from production. A lot of time, the challenge people have currently is they are running with sample data, which might be older data, and it may not be reflecting exact the production data set or production environment. So in this case, we are bringing the latest production data, importing it in a 0 copy operation, and then running the ETL job. So while this thing is running, I'll just quickly walk through. This is our samples repository, which you saw the QR code in the beginning, and everything is, this example is inside the standalone example. So if you go inside that, there's a Databricks CI/CD sample here, and all the code, everything I'm using today, everything is included here, including we have Scala example also. If you want to run Scala, if you are running Scala in your Databricks environment, there is a similar example for Scala also. And this will walk through the prerequisites, of course, Databricks and Git and lakeFS, and then the configuration, like saving your secrets, and everything is configurable through environment variables. So you'll basically define your environment variables, so you don't have to change any code in the samples. Everything is through environment variable. And then there is a demo instructions, which you just saw, and also for demo instruction for Scala. Plus, there's some useful links here, like how this was, any information you need to do the coding in case you want to customize anything, and some additional Git action useful code here. I will not go through all this, but let's go back here. And looks like this thing failed again. Let's check. I was hoping it will succeed this time. Well, let's see. This is demo, so things go wrong. Let's check here. This one is create lakeFS repo field.
Save and outputs. Yeah, this is the beauty of a live demo.
Yeah.
Um,
There's some problem here. The import, for some reason, the import failed. So let me just, so let's rerun. This is the real test, a real demo. So let's rerun this, and I'm
Yeah.
going to retry this and see. So while this thing is running, I want to quickly show the action, like how the action is configured. So let's
the
look.
GitHub action, you mean?
Yes, GitHub action, yes.
Yeah.
So let's look into the action code. Let it run. So let's go to that code. So this is a YAML file for running the GitHub action. If you're familiar with running Git actions, so it's done through a YAML file. So it's highly configurable. And this action is going to run on a pull request. And here we are passing the Databricks host and token. Again, token is saved as a secret in Git repo, so it's not exposed. And here, first thing we do, we check out the repository, and then we create the Databricks workspace and import all the code we are running. So you can use your existing workspace or the shared workspace or the user workspace in your Databricks environment. And then we are going to import these code because the code is changing. So anytime you make any change, we are going to import that the new code into Databricks environment. And the next step is to create the sample delta table here. So as I mentioned earlier, we are using those two tables. So we are creating those two tables through a notebook. But if you have your existing tables, you can use that also. Then after that, this is the step to run the create the lakeFS repository and import the data set. I think it's finished, but I'll come back to
yeah. Looks like it's passed now.
So here you'll see that we are passing all these parameters to the notebook. In this case, including the environment stuff and providing the existing cluster ID. So you can run this against the existing cluster, or you can create a new cluster. Sometimes people want to run this in a new cluster, create a new cluster and tear it down once it is done, the testing is done. So in the README, you'll find an example how to create a new cluster on the fly, Databricks cluster on the fly, and run your notebooks. So I think most of the things is pretty obvious now, triggering another Databricks notebook to run the validation check. And finally, look at if the validation was successful or failure. So we look for the success message. And if it is not, then we failed this Git action. Right now, this one succeeded. So in this case, you can see at the end, let's check the field for field validation. So everything was successfully done. So that's what you can this way you can automate the whole your testing process, ETL testing process against your real production data. I think that's pretty much.
Yeah, that was a great demo. Thank you so much. I actually wouldn't mind as I take over and I give you a few other notes, I wouldn't mind asking everybody in a poll if this was helpful. If you can spin that up.
Yeah.
And in the meantime, thank you. Just I'll give this is a really, really short poll, so we'll wait 10 seconds. And in the meantime, I'll share some more useful things over here with you with everybody. So first of all, as mentioned before, lakeFS is open source. Everything that we saw today was part of the lakeFS open source solution. We also, I mean, we're a commercial company. We also have paid offerings, both lakeFS Cloud and lakeFS Enterprise have enterprise features such as RBAC, SSO, mirroring, things like that, SCIM, and so on. And Of course, lakeFS Cloud has the advantage of also being a hosted solution. So we scale it, we maintain it, we patch it, we take care of manage garbage collection, and we take care of the compute as well. If you want to learn more and you're interested in data and AI, then chances are that at least some of us here on this call are going to attend the Data and AI Summit in San Francisco. I want to say next month, right? Yeah,
Yep.
next month. So
Yep.
we're going to be there also. We're going to be at booth 69. So please come by and ask questions. We'd love to walk you through more details. And of course, I don't want to finish without saying that we also have a very active Slack community. Would love to have all of you join our Slack, ask questions, and so on.